Good morning to everyone. I hope you can see my screen and you can hear my voice. Welcome to this international conference, Shaping Light for Health and Wellbeing in Cities. We are really happy to host you here, even if virtually. Our aim was to have a conference in presence, but it is still very difficult to organize this sort of events in this situation, but hopefully we will have more events in the future and we will have the opportunity to meet again in presence and discuss about health and well-being linked with lighting in cities soon. So my name is Simona Tondelli, together with my colleague Valerio Carelli. I'm the coordinator of this Horizon 2020 project, ENLIGHTENme, which is organizing this international conference. The aim of the conference is to help us building the knowledge about lighting, health and well-being, and so to build the basis for us to go on with our studies about innovative policies for improving citizens' health and well-being, addressing indoor and outdoor lighting. Our project was funded under Horizon 2020. We started working together in March this year, so we are working together since about 6 months, and the project will last for 4 years, so we still have a long path in front of us, so we hope really to have results and evidence to share with you before the end of the project. Our consortium is quite big. We are 22 partners from different EU countries and from the United States. As you can see from this slide, the consortium is made by universities. The University of Bologna is the lead partner of the project. Research centers, but also 3 cities are involved, companies, SMEs, networks. So we are a very diversified group of institutions working together on these complex but also challenging topics of health and well-being linked to urban lighting. Why did we choose to focus on lighting? We all know that there is an exponential increase of human exposure to electric light at night due to many different causes: public outdoor illumination, artificial sky glow, but also to direct exposure at individual level from domestic lighting, screens, smartphones, etc. It is clear that this exposure can profoundly affect people's circadian rhythm, health and well-being. So our idea is to study these linkages, these connections, in particular by focusing on the effects of lighting on older adults. We focus on these specific groups of older adults because they are more sensible to this problem, but also because they really are a big group of the EU population, and the number is projected to increase in the next few years. Health and well-being are both affected by lighting, so we are going to study the effects of public outdoor and indoor lighting exposure on our well-being, on our physical health, but also on our mental health and on our well-being. So we will deal with the many different aspects of health and well-being linked with artificial lighting exposure. The objectives of the project are at the end to improve older adults' health and well-being by addressing public policies related to indoor and outdoor lighting. By doing this, we tackle many different sustainable development goals. First of all, goals about health, but also about quality of life, about sustainable communities, and so on. To reach this wide overarching objective, we will work on many different specific objectives. So first of all, our aim, and we are focused now in this first part of the project on this activity, we want to collect, review, and represent global evidence on indoor and outdoor lighting impacts. And this conference is part of this first activity, and also of the second objective, so to promote knowledge exchange in urban lighting policy research and healthy citizen behavior. So you will help us in this two-day conference to work on these two specific objectives that we have defined. Then, basing on this, we will co-design lighting policies within urban lighting labs established in the 3 cities that are members of our consortium, working with citizens, with local stakeholders, to really understand what is needed for improving their health and well-being. We will assess and establish the impact of urban lighting on circadian rhythms photoentertainment through some experiments. We will then be able to provide tools to support the decision-making process, and our aim is also to scale up and tailor the policies to other different contexts. So not to stop to our 3 cities, but also to provide guidelines that may be applied in other cities all around the world. We also want to cooperate with companies, with the market, to enhance the market uptake of the innovation that we will develop. And we also would like to work on education and capacity building by introducing new skills in the local institution, local administration, really to focus on health as a transversal topic to be addressed by all the policies that are tackled by the municipalities. This is our paradigm. We will work by keeping in mind that people are our main interest, our main focus. So we will work both on the social and physical and aspects of impacts of light by addressing social interaction, safety and security, but also circadian rhythm, mental illness, and other neurodegenerative diseases. And to do this, we will study the effects of both indoor and outdoor lighting. We will study how outdoor lighting is connected with the urban fabric and with the activities that take place in our cities, and how our habits also are influenced by light and can influence the exposure to light. For doing all these activities, we will of course keep together many different approaches. We will work on urban policies, but as I have already mentioned, we will also tackle technologies and the market. We will address health research, but we will also work a lot in awareness raising and engage stakeholders and citizens in the co-creation of solutions. And we will build capacity for people to address these topics. As I said before, we are a large consortium of experts, of cities, of networks, but we also want to enlarge our capacity of discussing and finding solutions by engaging other partners, other stakeholders and experts. For this reason, we have established a scientific advisory board that will help us, give us advice about our findings, but we also have 2 other boards that have been already established. One board of cities, let's say, bringing together policymakers, mayors, and urban planners from many different cities, not only from Europe, but around the world, really to work on this possibility to scaling up the solutions and the policy guidelines that we will develop in many different contexts. So they will act as a part of our discussion, will give us advice, and will help us in finding the a solution that can be adapted in different contexts. At the same time, we have established the board of lighting companies with designers, producers, and managers really to try to build a bridge between the two different worlds of production, of design, and of the users that are cities and citizens. So to try also to influence the market in addressing the solutions that can really ensure an improvement on health and well-being. The main phases of our project are knowledge building, and we are in this phase now. We are really trying to gather the knowledge about this topic, and then we will start soon next year in building evidence about the effects, the impacts of lighting on health and well-being by building experiments and by discussing with citizens in 3 different cities, Bologna, Amsterdam, and Tartu. And then we will go to the final phase of exploitation of the results that we have gathered through the building of guidelines and tools to be made available for everyone. So the first phase, which is already in place, consists in developing a GIS-based platform for organizing the existing knowledge and the new knowledge that we will produce through ENLIGHTENme about the impact of light on people's health and well-being. So we started by building a common operational language, because this is one of the problems when you put together many different expertise and approaches, so to understand what we are talking about. And then we are also collecting and representing on this platform good practices on urban lighting in a sort of web atlas that will be open, so available for everyone to be studied. And then we are also working on a more detailed level on the 3 cities that are a part of our consortium to build maps about socioeconomic aspects, urban and lighting aspects, and health condition, in order to try to find more vulnerable areas in the cities where to focus with our studies. At the end, when we will also have some results from our pilots, we will also build 3D urban models to help the decision-making process in taking decision, considering also the impact of lighting on health and well-being. So the atlas will be built on different levels. There will be this wider level about good practices collected all over the world. And thank you for participating to this conference, because through the discussion of the next 2 days, we will also collect new evidence, new good practices to be put on our atlas. And it will be possible to make queries, to look for information, to find example. And this, as I was saying, will be open to everyone. We are now working a lot on this definition of lighting and health maps by trying to put together different data sources, integrating sources and data from the 3 cities, by trying to represent together in different layers socioeconomic, urban, lighting, and health aspects. The results that we aim to have in the next couple of months is the identification of vulnerable districts where to focus for our next phases of the project. So the cities, as I already said, are Bologna, Amsterdam, and Tartu, that were chosen for having different latitudes, so different conditions of natural lighting, but also different conditions of habits of behavior from the citizens, so that we will be able to study the different impacts of electric, artificial light according to the different natural lighting condition, but also habits of staying out at night, for example. At the end of this process, we will also provide a simulation tool for the cities, for local municipalities, to try to assess, to understand, to assess before doing some interventions, which could be the impact of those interventions. In the next few months, we are also starting to build our evidence building phase, because once we will have chosen the district where to deepen our studies, we will start to establish urban lighting labs where to engage communities and cities in defining solutions for improving quality of life. In those areas, we will also define the intervention, new innovative lighting installations, and we will establish this lighting installation in a small part of the districts to test the effects of this innovation on people's health and well-being. And by doing this, we will assess the impact of both outdoor installations and indoor lighting innovation on the circadian rhythms of a group of people that will be recruited. We will recruit 500 participants for each city. Half of them will be selected within the pilot area where we will implement the lighting innovations, and half of them out of this pilot area to have a sort of control population. We will perform a baseline study before the changing of the lighting installations and 1 year after it, in order to assess differences. And we will then try to draw conclusions about the effects of this 1 year experimental change of lighting on people's health and well-being. This will help us in the last part of the project to build policies and guidelines to support the decision-making process in improving the quality of life, health and well-being of the citizens for what concerns the policies in the field of lighting. So we will develop healthy urban lighting good practice guidelines to support the development by the local municipalities of lighting master plans and smart city programs. We will develop a decision support system to provide a tool to support the decisions and to build different scenarios, helping the policymaker to understand the different impacts in terms of health, well-being, cost, and environmental impact of the solutions that will be proposed. And we will also try to disseminate our results by policy briefs. We are also part of a cluster that has been established by the 6 projects that were funded by the Commission under the same topic of urban health, with the aim to improve and safeguard the health and well-being of citizens. So we have started to work together to boost the visibility of the results of the projects, to build also stronger contributions to the policies in terms of urban health, to facilitate international cooperation. So we also will organize events under this group of the urban health cluster, and we will disseminate those events. So we are happy if you want also to join us in this in this initiative. Now just a very short presentation of the conference program scheme. So we have started now with the plenary session. In a few minutes, you will have the possibility to listen to 2 keynote speakers, Russell Foster and Lucy Kimbell. Then in the afternoon, we will start with our parallel sessions about social lighting and lighting technology for urban well-being, and artificial lighting and its implication for health, well-being, and circadian rhythm in the afternoon of today. Tomorrow morning, again, we will have 2 parallel sessions about urban analytics and innovative urban lighting policies for health and well-being, and about ethical and legal and social aspects of urban lighting and related health studies. And we will be together again in a plenary session in the afternoon of tomorrow to draw conclusion, to listen from the discussant and the chairs of the different sessions about the results of their discussion, and to draw some conclusion together. Thank you again for joining us, and I now leave the floor to my colleague, Professor Elisa Conticelli, that I would like to thank because she was really great in organizing this. Also thank to Dr. Giulia Marzani that also helped in organizing this conference. And I wish you will enjoy these 2 days of discussion, and that it will be very fruitful for all of us. Thank you again.
Thank you, Simona, and welcome to everybody to this important event for our project. And it's a pleasure for me to introduce the first keynote speaker, Professor Russell Foster, who is Professor of Circadian Neuroscience, Director of the Sleep and Circadian Neuroscience Institute, Head of the Nuffield Laboratory of Ophthalmology at the University of Oxford, and then Fellow at Brasenose College.
I'm here.
Okay, great. Welcome, really welcome to Professor Foster. And I would like also to introduce the speech that is titled "The Biology of Human Light Exposure, Circadian Rhythm, Sleep and Health."
Thank you very much indeed. Really is a great honor to join you all this morning. I'll share my screen. Let's see if I can find, there we go.
In the bottom of the window.
Yep.
Okay.
Can everybody see this?
Yes.
Wonderful, wonderful.
Great. The floor is
super.
yours.
Well, thank you very much indeed, Simona and Valerio. I mean, I really am very, very delighted to join you this morning. And in fact, from Simona's introduction, I think that our philosophy about light maps on to each other absolutely perfectly. So I hope this is not going to be too boring for many of you in the audience today. So as Eliza said, I want to talk about sort of an overview of the biology of human light exposure, circadian rhythms, sleep and health. And my talk objectives are to essentially highlight the importance of circadian rhythms and sleep for health, to talk about the importance, and I think this is a really important part of the presentation, the complexity of light as a regulator of circadian rhythms and sleep. And that will, I think, really be the main focus of my presentation. And then finish with, in my view, what needs to be done to develop a truly human-centric lighting systems. What knowledge do we need to gain? And I see that's really at the heart of the ENLIGHTENme project. And anywhere going forward I can help, I will be, of course, delighted to participate. I've divided the presentation into these 5 sections: brief introduction about light and circadian rhythms, a discussion about the discovery of this third ocular photoreceptor, which is so very different from visual responses, the importance of light, just a little bit on essentially what goes wrong with circadian rhythms if we don't get a robust light-dark cycle, then critical features of the light environment, what should we be measuring, how can we measure these things, and then finally a brief section on what we need to do to develop an evidence-based lighting system. So let's kick off with the introduction. And something that is desperately obvious, but I think it's worth emphasizing, is that we sit on this planet, which revolves once every 24 hours. And of course, what that does is generate the day-night cycle. And this is such a profound change that all life on Earth has developed, has evolved a response. And in humans, of course, we have the 2 stages of sleep and consciousness. typified by physical inactivity and physical activity. And of course, as I will hope to emphasize, sleep is not a phase where we're doing nothing. In fact, the quality of our sleep will define the quality of our consciousness. So many important things are going on whilst we sleep. But the important thing is that the circadian system is capable of anticipating these 24-hour light-dark cycles and is adjusting physiology and behavior in advance of these changing conditions. And let me just give you a few illustrations here. So we see 6 blocks here, and we see a time base here of 2 p.m. to 2 p.m., so 24-hour time base, and the gray area here is nighttime. And the first profile I'll show is of melatonin. And the key point about this, and incidentally, if we get a chance to discuss it, melatonin is emphatically not a sleep hormone. It's a biological marker of the dark. In fact, it only has the very mildest effects upon sleep. And so we should perhaps talk about that at some point. But the point is, with this curve, you see that melatonin levels are rising in anticipation of the night, and that they are declining in anticipation of the morning. So this is not a light-dark driven change. This is essentially driven by an internal representation of the day, the circadian rhythm. And essentially any parameter you care to measure, as illustrated here, whether it be growth hormone, whether it be core body temperature, and indeed this drop in core body temperature may well be very important in sleep initiation. Cortisol, this morning rise in cortisol, the stress hormone, in anticipation of activity, testosterone peaking in the early hours of the morning, and indeed our ability to process information. A low point around about 4 o'clock in the morning, rising in anticipation with increased activity and the ability to, and the need to process information. Okay, the point is, what the circadian system does is fine-tune physiology, and this is absolutely crucial for our ability to function. And I'll touch upon this in a little bit more detail later on. I just want to also talk about the consequences of a dynamic physiology. And I could give 3 lectures on this, as I do for my undergraduates. But really, I want to just emphasize with a couple of examples that because we have such a dynamic physiology, we are not the same creature at different times of the day. And indeed, the action of drugs and interventions will vary across the day. And I want to give you a couple of examples of that. This is an example, a fairly chilling example, published in 2016, which is the impact of the time of day of whole brain radiotherapy on survival in patients with multiple brain tumors. It was a randomized controlled trial. Radiotherapy was delivered at 8 a.m. to 11 a.m., 11 a.m. to 2 p.m., or 2 p.m. to 5 p.m. And I have to say the results are rather chilling. So the 8 a.m. group were all dead by around about 6 months. The 11 a.m. to 2 p.m. were all dead by 24 months. And the 2 p.m. to 5 p.m., 10% were still alive at 36 months. And this sort of illustrates the fact that time of day is really important. And a rather relevant example is the time of immunization. This is a particular study on the influenza vaccine, the H1N1, in elderly individuals. And there was either a morning or an afternoon vaccination. And what we see on this axis here is the antibody titer. How effective was that vaccine at generating an antibody response? And we'll start with the baseline, which is here, and then look at the follow-up levels of antibody. So this is the afternoon vaccination, and there was an antibody response which went from around about 0 to 100. If we now look at the morning vaccination, you see that the antibody response went up to about 400. So same vaccine given at the same dose, but at different times had a very profoundly different response in generating an antibody response. And indeed, studies are going on to see if vaccination against the COVID-19 virus is also similarly affected by time of day. I just wanted to really emphasize in these early slides that time of day matters. And of course, this will be familiar to many of you. Let's now touch on the generation of circadian rhythms. And again, I apologize if this is familiar to many of you. We look at the brain here, and we look at the anterior hypothalamus. And of course, in frontal section, we see the hypothalamus here. And this is the optic chiasm, where the optic nerves enter the brain and fuse. And just above the optic chiasm, we have the suprachiasmatic nuclei. It comprises about 50,000 individual cells, which are coupled together, these individual SCN neurons. And if we enlarge the nucleus of one of those neurons, we see that in the nucleus, we see the clock genes. And of course, they're activated. They produce clock proteins. And critically, those clock proteins are then capable of entering the nucleus and actually inhibiting further clock gene production. So the net effect is, over time, an oscillation of clock gene production and then degradation, because those proteins, once they're produced, are subject to degradation. So you have this wonderful feedback loop of generating this circadian oscillation. And this is really at the heart of our circadian rhythms. Now, that's how the clock is generated. Let's now touch on the importance of light. So here we see a 24-hour cycle of clock protein productions, but it's entrained, it's locked on to a light-dark cycle. And the key point I want to emphasize here is that the time, the peak of protein production, clock protein production, is occurring at the same time every day. Now, if we disrupt that light-dark cycle, and the most dramatic form of that is to plunge the individual into complete darkness, the effect, of course, is the clock still ticks, but you'll note that that timing gets later and later and later in time. And so light is absolutely critical for aligning the internal day to the external world. So the key point I want to consider next is, how is this master clock, the suprachiasmatic nuclei, entrained by light? Which leads me to the second topic, which is the discovery of this third ocular photoreceptor within the brain. Now, the point I want to emphasize right from the beginning is that the eye has dual functions. Of course, its familiar function is as an image detector, either black and white, detecting an object against its background, but also using color as an extra channel to identify an object against its background in terms of color contrast. And most lighting systems, as you guys will be familiar with, are designed to enhance vision. But the other almost separate function of the eye, as we'll see, is for non-image forming light detection, which is using overall levels of light within the environment. And I'll talk about this stimulus in more detail later on, for the regulation of a range of different aspects of physiology. I'll talk about circadian rhythms, a little bit about sleep, but also be aware that this other function of the eye, this non-image forming light detection, is modulating alertness, mood, cognition, pupil constriction. It's actually impacting upon the visual system. It feeds back. It can regulate metabolism, hormone release, such as melatonin. Light will inhibit melatonin, whilst it will stimulate the release of serotonin and dopamine under certain conditions. Let's just focus upon circadian rhythms. Now, here we see the sleep-wake cycle, and just want to, in cartoon form, illustrate what I mean. So here we see this is a human, so this is the nighttime, this is the duration of sleep, and you see that sleep is occurring roughly at the same time every day. If we then plunge that individual into darkness, as illustrated here, then we see that for most humans, the sleep-wake cycle will drift later in time. Most of us, but not all, have an endogenous clock that is slightly longer than 24 hours. So under constant conditions, we'll want to get up later and later. And of course, we call this the entrained rhythm versus the free-running rhythm. And the point of this slide is really to emphasize that you have to have your eyes to entrain. If you have eye loss or severe damage, then this ability to entrain is lost, and the free-running condition kicks in. And we're studying this in profoundly blind individuals, both in the UK and the United States. Okay, so it's the eye, and You will remember some studies, some time ago, suggesting that the back of the knee might be light sensitive, and other structures. Complete nonsense, it is exclusively the eye. So the eye, we know, is detecting the light, and there's a direct projection from the eye called the retinal hypothalamic tract, which is innervating the suprachiasmatic nuclei. So there's a direct light input to the master clock within the brain. So how does the eye detect this light for clock regulation? So if we expand and we look at the retina in some detail, here we have the rods illustrated here in green, and the various cones, which of course are the visual cells, which collect light information. And this is the inner retina doing the first stages of visual processing before the ganglion cells fire off the information into the brain for visual light detection. And what was extraordinary, and first we did this in mice and then humans, is that we showed that actually you don't need your rods and cones, your visual cells, to detect the light-dark cycle for the regulation of the clock. And over 10, 15 years of work led to the discovery that there's a third class of photoreceptor within the eye based upon a small number of these ganglion cells. About 1% are directly light sensitive, and they are responsible for conveying light-dark information into the master clock, the suprachiasmatic nuclei. And we know that this new photoreceptor is based upon a photopigment, which is called melanopsin, or OPN4. This is what these extraordinary cells look like. They form this photosensitive net throughout the eye. This is at higher power and even higher power. They're quite exquisite, beautiful cells, quite large actually. We also know that in mouse models and of course in humans, this sensitivity of those photosensitive retinal ganglion cells is peaking at the blue part of the spectrum at 480 nanometers. So we can add this in a sense additional light channel to the light information detected by the eye. So here we have the spectral sensitivity of the rods peaking around about 500 nanometers. The short wavelength cone at 420 nanometers in the sort of purple bluish or sort of ultra blue area of the spectrum. We have a medium wavelength sensitive cone and a long wavelength sensitive cone, respectively sensitive at 530 and at 560 nanometers. So we have quite a broad spectral input, and I'll come back to this point fairly shortly. Okay, so that's sort of the introduction. I want to now just sort of emphasize the importance of light. Abnormal, poor, or no light exposure to the 24-hour light-dark cycle can lead to multiple problems with sleep-wake regulation. And I just want to illustrate some of those problems. So here we see a cartoon again, and we see that the central gray bar here is relatively nighttime. The horizontal black bars are roughly when the individual is asleep. And this is sort of so-called normal person. They're going to bed at, at a fairly stable time, maybe going to bed a little bit later over the weekend and getting up a little bit later over the weekend, but it's a broadly stable sleep-wake cycle. If we now, seem to have, there we go. We can get advanced sleep depending upon when you see light. So if you're seeing lots and lots of morning light, but no evening light, then this will advance the clock. And this is something I'll talk about later. If you're seeing very little morning light, but lots of evening light, you can delay the clock massively. If you're not seeing any light at all, or you have no eyes, then we've seen this pattern before. You're free running, you're drifting through time. This is quite a common feature in psychiatric illness and indeed the elderly. You can have profoundly fragmented sleep if there's both a problem with the clock and the failure to have a robust light input. Again, in the elderly, this can be quite important as the circadian amplitude begins to drop, and in the absence of a strong light-dark cycle, 24-hour patterns of activity can fall apart. This is very common, of course, in dementia. And finally, a common sort of feature broadly called insomnia, the failure to go to sleep when you want to, the failure to stay asleep, waking up early, associated with daytime sleepiness, occurs in very many different groups, mental health neurodevelopmental disease, and the elderly. Again, all made worse by poor light-dark exposure. Sleep and circadian rhythm disruption, a term we've called SCARD, is the result of both relatively minor short-term and both long-term sleep-wake disruption. And let me give you an illustration of that. So there are short-term effects, long-term effects of sleep and circadian rhythm disruption, and of course, there's a big impact on those individuals who are vulnerable to mental illness and an exacerbation of symptoms. And of course, all of these different long-term, short-term, and mental illness vulnerability are interlinked. And at this point, I don't know whether it's Christmas or not, but I thought, oh my goodness, it's a Christmas angel. And so I'll finish the picture, which is the avenging angel of Christmas, of circadian rhythm disruption and sleep loss. And so let's now populate this with some examples. So short-term circadian rhythm disruption and sleep disruption, microsleeps, this uncontrollable wanting to sleep. 100,000 crashes on the American freeway every year are associated with microsleeps, and that's probably an underestimate. Changes in mood and the way one interacts with others, loss of empathy, frustration, irritability, reduced creativity, poor attention, poor motivation, memory impairment, and negative focus, and indeed irritability. And this can happen over a relatively short period of time. Longer sleep-wake disruption as a result of abnormal light-dark exposure, for example, in night shift workers, but also in the hospital environment. We shouldn't forget that. Physiological stress, psychosocial stress, immune suppression, which is possibly the result of increased stress response, leading to increased infection, increased cancer risk, cardiovascular disease, increased stimulant use, increased sedative use, metabolic abnormalities, of which there are many, such as obesity, but also diabetes too. And then the final domain, those individuals who show mental illness vulnerability, an exacerbation of symptoms such as mood instability, depression, anxiety, substance abuse, hallucinatory experiences, paranoia, mania, and feelings of rejection. And these are all tangible results of sleep and circadian rhythm disruption, which can occur as a result of poor or weak or abnormal light-dark exposure. So these are really important, major impacts across our health and well-being. I just want to give you one example of where light has been shown to be incredibly important in the field of depression and probably associated with the stabilization of the sleep-wake cycle. So this is a study which looked over 8 weeks at a reduction in levels of depression, and this was the placebo, showing that there was a significant reduction after 8 weeks with a placebo. The next intervention was fluoxetine or Prozac, which actually was only statistically different from placebo after 8 weeks. But this is, I think, the most extraordinary result. This is light. Statistically different after 2 weeks of exposure to 10,000 lux from a light box for 30 minutes in the morning, and very, very different from fluoxetine and placebo after 8 weeks. Interestingly, fluoxetine plus light seem to have an additive response, suggesting that there are different mechanisms whereby light and fluoxetine are having their effect upon depression. But I think this is a really good example of where light as an intervention in the morning can have a big effect upon levels of depression. And again, we can talk more about this at later sessions. Okay, now I want to consider what are the critical features of the light environment that are underpinning those health conditions and that disruption that I talked about earlier. And I suppose the first thing to point out is that the light environment that's required for circadian and sleep-wake regulation is very complicated. It will depend upon the intensity of the light, its duration, its color or its wavelength, the time of light exposure, which is often overlooked, the task, whether it's a circadian measure, whether it's alertness or whether it's the regulation of melatonin, one's light history. whether you're an agricultural worker spending lots of time outside, or you're spending all of your time inside, as you find in many individuals in nursing homes. And relating to that, age. I'll touch on this shortly, but one's age can have a big effect upon one's overall sensitivity to light. And these are the key parameters that need to be teased apart. Let me give you some examples of the importance of most of these domains. And we'll start with light intensity. And this is a cartoon again, and the light intensities are measured in lux. And you see, of course, the environmental range from moonlight, 0.01 lux, through to sort of 50 lux in a museum display case. Home and office lighting conditions, very variable, actually ranging from 50 to sort of 400 lux. And you guys will know better than I will about measuring internal light levels. Early morning, 3000 lux, near a window. During the day, 3000 lux if you're lucky. Shade outside, 10,000 lux. And full sun, even in places like England, can get to 100,000 lux. Now, the key point is that the different receptors in the eye have different sensitivities. So rod vision is of course, detected in a millisecond range. So you only need a few milliseconds to detect light from 0.1 lux all the way through to saturation at about 100 lux. Again, the cones, less sensitive to light, but even with millisecond light exposure, they can detect color from around about 10 lux all the way through before saturation at 100,000 lux. What about those photosensitive retinal ganglion cells? Well, where they're sensitive is a matter of debate, and I'll unpack that in a little bit more in a moment. But we can say broadly between 50 to 100 lux or so, and saturating, you know, in brighter light intensities. However, the absolutely critical point, and I'll make this point again in the next slide, but whilst the rods and cones need light exposure in the fraction of a second, in the millisecond range, the photosensitive retinal ganglion cells, the circadian system, needs bright light, relatively bright light, for hours, certainly 30 minutes or more. And we'll come back to that in just a second. So the point, often it's very confused. Comparing rods and cones of the photosensitive retinal ganglion cells can be deeply misleading, because this direct comparison, as in the last slide, doesn't take into account the light exposure duration. As I say, rods and cones in the millisecond range, the photosensitive retinal ganglion cells, the minute to hour range, which I want to sort of talk about in a little bit more detail and unpack this whole issue of duration. So this is a slide that's being prepared as part of a new paper by my colleague Stuart Pearson, and actually it's basically not that dissimilar from other papers. For example, papers by Jamie Zeitzer, for example, where we have the lux range on this axis here and the response on this axis. Evening domestic light is sort of indicated in this range, so threshold is around about here. So threshold for the PRGCs in this assay was around about 50 to 100 lux. But this is a collection of data that use stimulus durations between 2 hours and 6.5 hours. And in fact, as I say, the Jamie Zeitzer paper, this wonderful early study, used light durations of 6.5 hours. So we're talking long duration light exposure to get an effect. And this raises the issue of light before bedtime. And this famous study about using a Kindle or an ebook before bed. What's the effect? Well, there was a lot of press coverage of this. Evening use of light emitting readers negatively affects sleep, circadian timing, and next morning alertness. Yes, but the results were very, very minor. So what they did was expose individuals to a print book or an ebook on its brightest light setting, which is around about 32 lux. And individuals read an ebook for 4 hours between 6 p.m. and 10 p.m. directly before bed on 5 consecutive nights. So it's 4 hours of this exposure, 5 consecutive nights. And if you look at the data and the way it's plotted, you think, my goodness, it's a big effect. Well, actually, it's 10 minutes. So sleep onset was delayed by 10 minutes after 4 hours of Kindle use on its brightest light setting, and there was a loss of REM sleep by only 10 minutes. So this is really minor stuff. And in fact, Mary Caskoden commented that, well, these data may be they may be statistically significant, but they're biologically meaningless. So we have to be very careful about what's being extracted from the literature in terms of our interpretation. This is sort of a minor effect, which is at the border of threshold for the circadian system. And as I say, this was 4 hours of light exposure. Okay, let's now look at wavelength and the color. And I mentioned earlier that the photosensitive retinal ganglion cells are peaking in the blue part of the spectrum. And we think often that it's blue light which is the most important for the regulation of the circadian system. However, again, we have to be careful because we now know that the cones can speak directly via cone bipolar cells to those photosensitive retinal ganglion cells. And the rods have a rod bipolar, which then communicates with an amacrine cell, which then communicates to a cone bipolar. And also you can get cone input. So the key point is that the 3 cone classes and the rods can all modulate the light activity of those photosensitive ganglion cells, which are then firing off their information into the brain and regulating the suprachiasmatic nuclei. So as we've sort of seen this slide before, but I just want to emphasize, the spectral breadth of the eye is very broad. And so we can't assume that just blue light is important. But we also can't assume that whilst there's a potentially a broad spectral input, we don't really know what these different spectral channels are actually doing, what information they're providing to those photosensitive retinal ganglion cells. There's data in the macaque, for example, that the short wavelength cone is actually inhibiting these channels. And this is something we'll come back to fairly shortly. Okay, so there's potentially a broad spectral input into the circadian system. It's not just blue light. So time of day. Now, as I said earlier, this is often hugely overlooked. And let me just again illustrate what I mean here. When you see light really matters. A cartoon, here we see a day-night cycle, and I've just sort of indicated the subsequent days of sleep onset. And what you see is that dusk light will delay the clock. So you'll go to bed later and get up later. Whilst dawn light will advance the clock. You'll go to sleep earlier and get up earlier. So the when you see light will affect sleep-wake timing profoundly. And to illustrate that, we did a study a few years ago, which was looking at the chronotype, morningness and eveningness, in an environmental light exposure in a student population. And what we showed is that the students who were sleeping through dawn and missing out the dawn signal, but were awake and getting the dusk signal, were showing a much later chronotype. So when they were seeing light, very much influenced their chronotype, and the more dusk light exposure they got and the less dawn light exposure they got, the later the chronotype that they were. Okay, so getting light exposure at the correct time is absolutely critical, at least knowing when you get light exposure. So dusk light delays the clock, dawn light advances the clock. So let's now look at the task. And this again is complicated. So the first point to make is I've kind of implied that there's only one type of photosensitive retinal ganglion cell. Well, in humans and mice and other sort of animals that have been studied, there are at least 5 and possibly 6 different morphological types of photosensitive or melanopsin expressing ganglion cell, and they project not just to the master clock in the suprachiasmatic nuclei here, but to many other structures associated with many behaviors. So for example, the olivary pretecton nuclei is involved in the pupil constriction. We talked about the SCN, the VELPO, the ventrolateral preoptic nuclei is involved in sleep-wake regulation. The lateral hypothalamus is not only involved in sleep and alertness, but also in metabolism. the subparaventricular zone is integrating circadian and metabolic information. We also know that there's a projection to the medial amygdala, which is regulating mood. We know that the dopamine system and the serotonin systems are being regulated by light and potentially by this system. There's a direct projection to those structures. Vision itself may be modulated by these photosensitive retinal ganglion cells via the lateral geniculate nucleus and the superior colliculus. We also know there's a projection to the sympathetic nervous system, which is regulating things like melatonin. And the assumption has been that these different responses to light all show the same sensitivities and dynamics. And we know that that's not the case. So for example, the shifting of the clock, the sensitivity for shifting the clock is rather different from the suppression of pineal melatonin. And pineal melatonin is often used as a surrogate measure for circadian regulation. So you have to be very careful about the assays that we use. And finally, the age of the individual. Now, we've known from animal studies, and this is one we did several years ago now, that there's a difference as individuals age. So these are young individuals, and these are old individuals. And this simply shows the activation of the master clock, the suprachiasmatic nuclei, by light. And we see that here's a young SCN, there's an old SCN, same light stimulus, and we show a very marked decline in the expression of, in this case, the early immediate gene FOS in response to light. Seisler's group showed that there's decreased sensitivity to phase delaying effects of moderate intensity light in older subjects, but it's not a completely clear picture. There was a study from this group here suggesting, although that there was a trend for older individuals to be less sensitive, in this case to dim light, this trend was not significant. But I think it's fair to say that there is a change in light sensitivity as we age. And indeed, it's some more recent studies showing that young people seem to be more light sensitive compared to more elderly people. Okay, so we've seen that the light stimulus is complicated. Its intensity, duration, wavelength, time of day, task, light history, and age dependent. It's complex. So how do you make biologically relevant measures for lighting design in domestic and commercial spaces? Now, the first attempt has been this important paper led by Rob Lucas and Stuart Pearson, colleagues of mine. Rob's now at Manchester, Stuart is a colleague of mine in Oxford. And what they did was develop an algorithm which integrated the different photoreceptor channels, the rods, the medium, the long, the short wavelength cones, and the Mendelopson system, and developed an integrated output about how effective that light stimulus might be. And the argument here is a new light set measurement strategy taking account of the complex photoreceptor inputs to these non-visual responses is proposed for use by researchers, and simple suggestions for artificial architectural lighting are provided for regulatory authorities, lighting manufacturers, design and engineers. I think it's a great first step, but we must be very careful, as these authors would point out, not to be misled by these models. Because, first of all, the assumption in this model is that all the photoreceptor inputs are additive. And there's good evidence that they're not. There's no account that the different receptors will respond to different intensities. There's no account of duration effects. There's no account of time of day effects. There's no account of the task. There's no account of the light history of the individual, and there's no account of the age. So whilst this is an important first step, it is absolutely not the answer to how we should use light information for the designing of internal spaces. Okay, we've talked about this. The key point is that the need to understand the ecology of human light exposure. And I know this is a point that Simona mentioned in the introduction. So what do we need to do for an evidence-based lighting design? Well, we need to ask the question, what is the direct impact of how much light, the type of light, and when the light exposure occurs on, in my view, three first parameters. First of all, the sleep-wake timing, alertness and cognition, and then overall well-being. And the point I want to make is that we can gather this information now with the technology that's currently available to us. So what we've seen this slide before, and we see that dusk light will delay the clock, and dawn light will advance the clock. But of course, we're exposed to an incredibly diverse set of experiences. What we're doing, rushing to work, sitting at our desk, playing football, maybe at lunchtime, eating, home TV, sleeping, and a shower in the morning. And of course, these will involve lots of different sorts of light exposure, from natural light to a whole range of different artificial lighting conditions. So we need to assess what's going on under these different situations. Where should the lighting industry, I guess, concentrate its efforts to achieve optimum health and performance, home versus work or combined? I think that's a really important question. And so we need to start to measure these different parameters. Well, you can measure rest activity, as I think Simona's slide suggested, using very simple ActiWatch devices. So you can measure when the individual is active. So they're going to bed after midnight here. There's a fairly ragged get up. You can broadly measure sleep onset and wake. You can collect urine over 48 hours, and you can measure the melatonin peak, which is an important, very independent measure of the circadian timing. And I'd like to come back to this at some point about why you need more than one measure of rest activity. So you can measure this stuff in the field relatively easily. You can also measure light exposure using simple devices like this. And you see here that light is superimposed upon activity. But now we can also use simple small spectroradiometers to measure the wavelength of light exposure. We can measure alertness and sleepiness using EEG. So there's different patterns of the EEG, can be associated with problem solving, concentration, busy, active, reflective, restful, drowsiness, or indeed sleep. And in the old days, of course, measuring EEG was a complete nightmare. You had to bring people into the laboratory. But there are a range of different devices now. This is a device by Dream, which is very using dry electrodes. You can pop it on, and the data that I'm aware that can be generated is rather good. So for field studies, these sorts of devices could be used to measure levels of activity, levels of alertness. Also, validated questionnaires. This happens to be one, the Hospital Anxiety and Depression Scale. So, for example, I can laugh and see the funny side of things as much as I always could, not quite as much, definitely not as much, not at all. We've used these scales quite extensively in a range of different studies. The great thing is that they're validated. The point I'm trying to make is that we can gather the data relatively easily these days. And so the key thing for me is that we can't develop human-centric lighting until we know what impact light has upon human biology across the day-night cycle. We must define human lighting ecology in the urban environment. And I know from Simona's introduction, that will be central to the ENLIGHTENme project. And I'm really excited that you guys are going to be taking this on. Okay, that's the end of my introduction. Just sort of to wind up, what I hope to provide was some introduction about the importance of light and circadian rhythms, the fact that we're dependent upon a third ocular photoreceptor to convey this light-dark information to us, the fact that if we don't get an appropriate light exposure, it's not simply feeling tired at an inconvenient time. The sleep-wake disruption that can occur from abnormal or disrupted light-dark exposure impacts across the health spectrum, from short-term problems in brain function to long-term health issues such as metabolic abnormalities, and indeed in those individuals who are vulnerable, minor to severe psychiatric illness. Then I talked about the critical features of the light environment that we know are important, but we haven't got a full handle on how they're integrated. Leading to the final point is that we should now be gathering sort of an evidence base for what's important for human light exposure, which will then ultimately give rise to informed lighting design. And so with that, I will finish, and thank you very much for your attention. I will stop sharing.
Thank you very much, Professor Foster, for this very inspiring and clear presentation. Also for me, that I'm just an urban planner. And I really think that you highlighted how important is could be our research and the result that we aim to achieve, and how much it would be challenging for us. I really hope that we will achieve important results.
I'm sure you will. And what's exciting for me is that, you know, you're at the vanguard of these really important questions and gathering a cohort of individuals who are passionate about solving them. So I congratulate you. And as I said, I'm delighted to help in any way I can.
Oh, really? It's really nice to hear this. Thank you again, really.
Oh, great. Well, thanks very much. Well, I seem to have overrun. I apologize. Oh dear, how embarrassing. See you later. Bye-bye.
Bye. Thank you. Thank you. And now this is the turn of our second keynote speaker, Lucy Kimbell, Professor Lucy Kimbell. Lucy Kimbell is Director, Social Design Institute and Professor of Contemporary Design Practices at University of the Arts, London. So welcome, Professor Kimbell.
Thank you, and really wonderful to be at your conference. Very impressed by the ambition and the project design. And I am going to follow Professor Foster with a very different kind of knowledge base, and I will share my screen.
Yeah, thank you. You can share by clicking on the icon in the bottom of the screen. In the meanwhile, I would like to introduce your speech that is about Studios for Society, how design research enables cross-disciplinary co-produced R&D. So very diverse topic, but anyway, very important also for us, for our project.
I've got problems sharing my screen because Google wants to record it or something. I'm sorry about this.
Usually, no problem. We will fix everything. Okay.
Okay, yeah. Right there, you can see yourself, and I will.
Yeah.
Okay, so thank you. Hello, and I'm going to. My aim in this talk is to share with you the proposition that design practices associated with the creative studio have characteristics that enable the translation of research insights into action, enabling R&D and societal innovation. So some of this is already built into your project, but I aim to add some maybe some insights from research about these activities, and so that you will deepen your understanding of design. And so my talk is structured. I'll briefly introduce myself. I'll offer a few definitions of design and the landscape of design. Some of you may be familiar, but some of you maybe not. Briefly look at the landscape of research and R&D, research and development. And then I'm going to add a little more detail, some quick examples of design or studio practices that have a relationship to R&D, and then suggest a couple of opportunities for your project to consider as you develop over the next few years. So briefly about me, I'm the director of a new part of University of the Arts London. University of the Arts London is a monotechnic of art, design, fashion, architecture, textiles, performance, screen, all of the creative arts disciplines formed of London's 6 historic art and design schools, and with 20,000 students. So we're quite a large institution, and we formed these new institutes to amplify some of the work of our research centres, and in particular connect creativity with social purpose. And my own background is a little varied. My original degree was engineering design. I ended up doing a master's in digital arts, and then ended up teaching and aligning myself really with the studio. And this picture here, I always like to show because it shows the mess of the studio. And it could be that Professor Foster's lab is a mess as well and looks like this. I'm not saying only creative studios are messy, but I hope you can see here in this picture the sort of huge variety of things going on, and sort of almost anything is possible. Although that's not quite true. It's, you know, within the traditions of the art school and the design school, these are spaces for exploration and inquiry. I then moved for some years. I was a research fellow at Said Business School at Oxford, so a business school, but there I took this studio approach into my teaching on the MBA for 15 years. So there's a class of my MBA students, obviously disrupting the logic of the pedagogy of the case study classroom in a business school, and getting the students to do making and exploration in the tradition of the design studio as part of their MBA education. And then I spent a year working in our government in the UK in a team called Policy Lab. And this is an example of a workshop that I helped run with civil servants, with policymakers, who, as you see here, are messing around with these very simple and cheap materials to explore what prototyping policy might look like. So I am going to start with a few definitions of design. So if you ask somebody in Western Europe or the global north, probably they'll think design is associated with something like that. Philippe Stark's lemon squeezer, a perfect example of late 20th century consumer culture. It's got form. Has it really got good function? I don't know how good it is for actually squeezing your lemons, but it's very much tied here, design, to consumption and production, to capitalism, to making things look beautiful and desirable, helping you demonstrate your status socially, and possibly helping you achieve things. And if you look at the curriculum or the courses offered by design and art colleges within the studio creative traditions such as mine, you can do a course, a bachelor's course or a master's course. It's usually tied to specific objects. So here, for example, from my university, you can do a course in ceramic design, in jewelry design, in product or furniture, or product and industrial. So it's tied to the objects. Your expertise, your knowledge, your skills is very much tied to the production of particular kinds of object. But then with digitalization and information communications technologies, design has shifted in various ways. And this quote from Steve Jobs, who was often considered a leading chief executive who paid attention to design and built that capability into Apple. He described it not simply about how things work, but actually in about how they design things fit in with or disrupt existing ways of doing things. So here making a link with social practices. And I took this photo in New York when I happened to be there when Steve Jobs died. And I happened to go to an Apple store and was amazed to see. You can see here these flowers and these post-it notes and that printout of an early Mac interface with the sad Mac face. So it's showing the sort of deep connection that some users of Apple had with a CEO of a business when he died. And what that says about the sort of growing visibility and role of design in consumer and technological culture. But there are other definitions of design. So this one from Herbert Simon, award-winning Nobel Prize winner, who was worked across many fields of knowledge, who paid attention to design. And this phrase, the first sentence here, everyone designs who devises courses of action aimed at existing situations into preferred ones. And basically saying that the transition from insight to action, from a plan to actually achieving that plan is a task of design. and making a case that many design practitioners and scholars have drawn on to say, oh, look, design is really important. We're not just about making things pretty or giving them form, we're actually about translations. And another thing that's happened in the last 10 to 15 years that's made design more visible is an articulation called design thinking, which says that the process and the practices associated with professional designers in that design school tradition are really important for innovation, and that that process, which has been studied in different ways, is something that can be adopted and used for organizational use and potentially for social use as well. And this is in particular associated with the leading global design consultancy, IDEO, with, for example, this paper from Harvard Business Review in 2008 and subsequent books and so on. And such is the dominance of this that this has been taken up by large firms. So, for example, IBM has adapted this idea of design thinking into their work. Obviously, they do software and services and solutions. So they have developed a design thinking capability. And you can see on the right-hand side, what's the benefit in business terms? It makes things faster. You get a return on investment, and you get your team to be more efficient. And things like this are spread across all sorts of global corporations. And they've also spread into governments. So in the UK government, a team that's been around for about, I think it's 10 years now, called the Government Digital Service, put a definition of design as central to the design of public digital services, and has gone on to win awards as well as be hugely influential. And interestingly here, look at number 1, start with user needs. So that language comes directly from design. You might ask, how do you know what user needs are? Where do you get that information? So that's a methodological question. But see, that's the first thing on their list is not achieve government policy, but start with user needs. And this is sort of putting into the heart of government something that potentially challenges what the government of the day is actually trying to achieve. And then we're seeing design emerge in lots of different institutional settings. So there's a recently completed EU project that worked across different urban centres in Europe to try and understand what happened if a design capability and design skills and methods were used in local context with local partners to achieve some kind of social outcome. And then, having studied across those, they've argued that there is indeed a distinctive kind of innovation which is design enabled, which they think has potential in urban environments to achieve urban problems at different scales. The European Commission itself, its Joint Research Centre, has developed a capability in the EU Policy Lab. This is an image from a project I worked on with them in finished in 2019, where they wanted to develop a citizen-centric perspective on what government would be like in 2030. And as part of that, one of the things they did was work with 6 design schools across Europe and set a brief to design students to imagine what the future of government would look like in 2030, and produce different scenarios and visions and provocations and product ideas and service experiences communicated in different ways, which then throw up questions about what government could be like and what government should be like. And then more recently, in the last year, the European Union again, Ursula von der Leyen about a year ago, announced the new European Bauhaus as an agenda for creating beautiful, sustainable and inclusive forms of living together. So directly adopting that language from the Bauhaus, the influential German art and design school of the 1920s, closed down by the Nazis, and then using that language and methods to say this is central to the future of Europe, although there's been quite a lot of challenges back to that narrative about what these terms actually mean and to what extent, who is defining beauty, what sustainability means to different populations, particularly through the extractive logic associated with modernism, and also the issues around diversity and inclusivity, given what late 20th century and early 21st century production and consumption look like, and the consequences for the climate. So I just wanted to give you a sense of the landscape of design. It's varied, it's got origins in commerce and business, it's spread across to government, and also is now integrated into research and R&D. And I wanted to just share this with some of you. I'm sure are very familiar with this, but this is the distinction between mode 1 and mode 2 knowledge production, where on the left, mode 1 knowledge is the idea of universal knowledge. It's about theory building and testing. Context doesn't matter. It's about logic and replicability and so on, and control. And then mode 2 is about the context of application. And it was wonderful to hear Professor Foster just now talk about the potential of your project to deliver some of the contextual knowledge about lighting in urban ecosystems. So I think you're probably doing a version of mode 2 knowledge, and I'm sure many of you are familiar with that idea. But in this landscape of mode 2 knowledge, there's a whole load of terms and sort of forms of it, from transition studies tied specifically to climate, responsible, R&I, mission-oriented, appreciative inquiry, and so on. There's a whole load of terms and methodologies and communities that coexist, within which design also exists. And I think there's some specific challenges in that landscape of research and innovation and R&D that design can contribute to, which is what I'm arguing. So one is the translation of research into action, whether action is frameworks for action or policy briefs, as you're going to do in your project, or working with manufacturers and urban with cities. There's the connecting R&D with lived experience. There's about how you do co-design, which obviously is built into your project. And then what happens when you bring disciplines into relation with one another, which you have in your project. So I think there's a number of challenges which design has something to offer. And I'm now going to just briefly show some examples, which I think will help illuminate that. So a little further on, how do we understand design? Because it exists in lots of places. It isn't a coherent discipline, really. There's only really about 40 years of study of it in universities, so it's quite a young discipline. But one of the ways design scholars, such as myself, are trying to understand it is the idea of abduction. So the logic of inquiry, which is not deduction with a hypothesis that you test, for example, through lab-based research, nor is it induction, which is where you look across a data set and try and identify themes, but actually something that, according to the philosopher Peirce, precedes that is the bit that's how do you get a hypothesis in the first place? Where do these things come from? So design scholars try and say, well, maybe what design is doing is a form of abductive research. It's the generation of a possible solution before you've even really understood what the problem is that you're trying to solve. Another way of trying to understand design at the moment draws on studies within science and technology, who have adopted another pragmatist philosopher's work, Whitehead, the idea of invention or inventiveness. And this idea is that inventiveness or novelty is not about the methods or the ideas, but about what the connections or arrangements between objects and activities. So it's contextual, it's contingent, and it's about opening up possibilities, not closing things down and defining them. Another example of a scholar who was trying to understand design is Armand Achouel from École de Nîmes, and his paper developed an idea of expandable rationality, again trying to explain what's special about design. And his version of it says, well, design expands the initial concepts. So you have some concepts, and through designing, basically they expand and you get unexpected results. And that happens by creating learning devices. That's what prototypes are. It's something that you create that is allows you to learn and continue to learn about what the problem and the solution are. And that it's absolutely based on social interactions and doing that work collectively. So the design process is a social process, and that allows you to understand the problem and the solution. And another example of scholars trying to understand and account for what's special about design draws on the idea of the studio as a centre of synthesis. And this could be contrasted, for example, with the sociologist Weber's account of bureaucracy as a locus of control and calculation. Instead, the studio, according to Wilkie and Michael, is the idea that the studio is a centre of synthesis. It's about bringing things together, heterogeneous elements, and sort of it could be, you know, could be almost anything that's combined in. It is a different kind of logic where synthesis matters. And then finally, just another idea from science technology studies is about trying to think how future imaginaries, how we could live, how we should live, what might happen to address climate change, or in your project, well-being for older citizens in urban environments, is how these things become imagined and stabilized. And some colleagues are trying to imagine the role and the practices of design within stabilizing future imaginaries. So that's just a few sort of theoretical or conceptual concepts which our scholars are using to try and understand and describe the sort of special things that design has. And I'm now just going to briefly summarize what that might look like, or does look like, in contemporary design practice and research that uses the mode of design. So one aspect is to take materials seriously. This picture comes from the materials library at my university, specifically the Central St. Martin's site where I'm based. So in that library, we have books, but we also have materials, because having access to materials and thinking about different materials and being able to use and borrow them is central to design practice. Another aspect of contemporary designing is using different ways of telling future stories, often with stakeholders or citizens or partners or users, about how things could be different. And co-design techniques, for example, often use storytelling, collaborative storytelling, to open up the work of imagining those futures. Another method within contemporary design practice, sometimes called speculative design, is the idea of creating an object from the future. This thing that you see here looks like a bill produced by a bit of government, but it's a future thing. It doesn't exist. It's from a bit of the UK government that doesn't exist, and it's embedded in a bit of infrastructure that doesn't exist. But the students produced this in response to the brief around the future of government 2030 that I mentioned earlier. So this is students from a service design master's at my institution, which was one of the higher education colleges involved in the EU Joint Research Centre EU Policy Lab project I mentioned earlier. So these students tried to imagine, well, what's the future of government? Well, government might find ways to hoover up data from your social media usage and other activities from that are tracking you and your usage, and then government might present you with a bill for tax that is based on your risk, that how much you might cost in the future. So it's sort of taking forward current developments around, for example, universal basic income and other social policy questions, and sort of pushing it a lot further and say, what would it be like if you as a citizen got a tax bill monthly from government about how much with your current behaviours you would cost government in the future, and that your tax is adjusted on a quite micro level based on your behaviours tracked by different entities that government has access to. So this is an example of this, the students are not proposing this, they're just saying, what would it be like, and what would you receive? Well, you'd receive a tax bill, and it might look something like this. And this is to provoke discussion and debate. It's a form of design which is about trying to imagine and materialize what possibilities might be like in the future. There are other traditions within the arts and design which are also about materializing as a way of bringing people together to experience something together. This image is of an artwork by an artist called Søren Dalgaard that was originally shown at a Biennale some years ago. This version of it is at a UN meeting about displacement and development, and it's curated by, sorry, I'm just trying to get rid of the little thing. Oh yeah, so this is curated by a PhD student, Hannah Entwistle-Chapuisat, who is as well as being a curator of these kinds of events in UN meetings. So she's bringing art experiences such as this artwork into UN meetings to try and engage the policymakers and the mode of policy making and discussion and the forms of knowledge that are present in those meetings. She's trying to disrupt those by bringing in artistic interventions. And this is, as you can see, an inflatable island. It's an island from the Maldives, and the artist basically invites participants to carry this island together, which then is, it's a piece of plastic, and you're walking around a meeting holding this piece of plastic, but then it prompts you to think about your relation and the possibilities and the implications of climate change and displacement due to climate and disaster. So these kinds of things are entirely ordinary and disrupt our current understandings about how to have such meetings and what sorts of forms of knowledge are possible. Another example of a political design intentionally is produced by this designer, Mark-Jan van Telling, where it's a chessboard produced. This is part of a project working with Palestinian designers and craftspeople. It's a chessboard where all the chess pieces fill the board. You can't play this game of chess. Every space is occupied, and there's no room for maneuver. And this then poses questions about the nature of life in the occupied territories. So this is a highly political form of design, but is also using the traditions of design to materialize, to create something that you touch and you could play with, although here playing chess is disrupted. There are also extensive traditions in the last 10 to 15 years in creating spaces for creative exploration by citizens, by users, sometimes called living labs, but actually these are the kind of living is where you're doing some making, connecting with other kinds of traditions such as maker spaces, and quite a lot of study of those and finding ways to involve citizens, create platforms for citizens to do their own creativity. So this is one by my colleagues at Central St Martin's working with a local community in London. And other ongoing things, other traditions within design is this, for example. So this is a student project which was looking at how a particular local council service could be for the future. And what you see here is the student with an older person who is currently a user of that local council service. And what you can see is the older person is looking at something that's basically a sort of paper and foam sort of iPad. It's not, they haven't built a technical prototype. It's literally a piece of paper and a piece of foam, but that allows the designer, the design student and the citizen or user to have a conversation about what that future service might be like. And in a sort of situated way, what would explore might it be like for them to use that thing that doesn't yet exist. And there's numerous other examples of connecting that mode of practice with scientific research. So this is an image from a project I did, a small project at the University of Warwick, where they have a lab for simulating connected and autonomous vehicles. So the sort of smart cars that are on the streets now, driverless cars. So they have a test lab which has a vehicle in it, and we connected some of these practices from design and participation to try and explore what is missing in the way that that engineering-led simulation has been built. And that led to a productive conversation with the engineering scholars who have built that infrastructure to test what driverless cars might be like and what they might do and how they might respond to environments, by bringing in some of the aspects to do with society that were kind of excluded in the way that that technological simulation was built. And then a couple more examples of working with scientists and technology. So this is a project that my colleagues at the Centre for Circular Design were involved in. This was a European project which involved material scientists who were designing new kinds of materials. But the design of a material is quite far away from how consumers interact with fabrics, which are in the form of clothes that they might wear. So in this project, the designers were not simply sort of at the end of the project life cycle, like, oh, here's a new material, you know, what can you do with it as a designer? What will fabrics change? The design then was became a central way for these disciplinary differences to be negotiated, and for the material scientists to have stronger links with what it might be like for users, for people wearing clothes, and for disposing of clothes and managing waste. So it became a sort of synthesizing element within this research project. And another colleague also from University of the Arts London is involved in a quite similar way, where design, the topic of the project is very different. It's about antimicrobial resistance, where again there's scientists who are expert in the diagnostics of infection, specifically urinary tract infection, in areas of where there's very limited health services, such as India. So working with those different scientists and with some technologists who were developing a new diagnostic for urinary tract infection, my design colleague and her postdoc were involved in, again, bringing together these elements of that system, we could call it, or that social system, to make the research connect more closely with social behaviours and social practices in rural India. So my colleague Guy Julia and I have tried to speculate about what this might mean, because these practices I've just shown you, are appearing in all these environments, different forms of sort of bureaucratic or institutional activity where there's an effort to try and create something new. And we've suggested maybe there's a form of mode 3 research, which design is particularly helpful with that intersection. So if you look at this image here from this animation we made, if we are trying to understand the intersection between research and change, or the actuality and the potentiality, that design is that scribble in the middle, where these practices that I've just shown you have something special that go on there. And we can see that in the institutionalization of design in projects such as yours, and the projects that the projects that I showed you. So what is design then? Well, we could say it's a social process that translates from insight to action, that it's using these practices of materialization and visualization. And in so doing, it's synthesizing and integrating diverse objects, actors, insights, and perspectives. So it's bringing things together. But it is operating within a logic of inquiry. I emphasize those words, what different ways people are trying to explain that. So the idea of abduction or invention. And this is important, that it's opening up possibilities. It's leading to new things that haven't been done before, and therefore producing unpredictable results, with the potential to reconfigure relations between people and systems, or between one discipline and another discipline, or between bureaucracies and people, and therefore is about potentially can reconfigure power relations. So this is where many of us working in design are trying to understand what this design stuff is and build this into the projects that we work on. And I now briefly just want to suggest a couple of examples for your project, knowing a little bit about your project design, but not that much. So forgive me if this is all obvious to you. First of all, so in that possibility, how to translate from insights, the research, into action, which obviously you've got built into your project. And I wonder if there's potential to use visual and material methods to translate the research insights into different formats to engage citizens, the manufacturers, municipalities, and other civil society partners. So you might take those 3D models and the urban maps that Simona was showing earlier and the scenarios and make them visible in other kinds of formats. So I showed you the example of the risk tax bill. It's like, what does the citizen get? What does the citizen touch? What does the citizen interact with? Which might be a very material thing tied into future infrastructures and organizational practices. Secondly, you have built in co-design with citizens into your project. That looks really exciting, the walks and the urban lighting labs that you're going to do. But I wondered if there's also possibilities to bring in co-design and prototyping very early on to engage the citizens in exploration, so it connects with their lived experience. And this picture here from a project I was involved in, and obviously those are young people, well, maybe it not be obvious, but they are younger people, and I know your project is emphasizing older people, but you can see there that sort of huge loads of mess of materials, just people, different ways of involving people in making stuff in a quite messy way where the stakes are low, right? Nobody has to be an expert to make a model out of junk. And those kind of methods are being used widely in the policy making context, an image I showed you earlier from UK government, as well as well established in co-design in lots of different settings. And then thirdly, is there a way of using these methods to bring into view different disciplinary perspectives, because your project has scientists as well as social scientists, as well as the perspectives of manufacturers and municipalities. And so is there a possibility of producing visual maps and stories about the project and who's in the project, and to actually do that kind of remaking of the project? Obviously, when any of us are doing grant applications for European funding projects, we have to use writing and Gantt charts and spreadsheets and so on. But what would happen if you took seriously the making of the project itself and the differences in the agendas, the understandings, the forms of knowledge and expertise that are built into the different disciplines and stakeholder perspectives? And if you used visual and material methods to reveal the project to yourselves and then possibly surface important differences and important forms of value that you may not yet have understood. So in this talk, I've tried to argue that design practices in the tradition of the studio have characteristics which are help with the translation of research into action, enabling R&D and societal innovation. And I've given you two examples from many different settings where that is happening, and tried to explain why scholars of design are trying to understand how we describe these kinds of things. And I leave you with a few questions. So you have co-design built into your project, but what is the potential to deepen that studio mode of inquiry in the project beyond the lighting labs? What might these materializing and visualizing practices reveal about the research assumptions, logics, and disciplinary relations built into the project design? Excuse me. And to what extent are project collaborators across your consortium open to unexpected insights and results, and what might follow from those? So I leave you with those questions. There are my contact details, and I'd be happy to continue the dialogue with you as a really important example of cross-disciplinary co-produced research to connect research and action in the world. Thank you.
Thank you, Professor Kimbell, for this very powerful speech. And I think that you really have highlighted how powerful and meaningful the design could be, and also multifaceted, because it's really nice to see that each part of our lives can be designed. And we really hope that we will use the most effective ways of co-designing good and right solutions for people that we are going to address. Thank you again for your speech. And I think that we have concluded this first plenary session, and I would like to invite Valerio Carelli to say a few words for everybody.
Thank you, Elisa. I will have very few comments, also because I have difficulties to talk. I think we had two wonderful lectures centering exactly the objective of our project, meaning the two keywords are transdisciplinary and cross-contamination. So we went from Russell Foster with an extremely clear landscape of the science behind our project to the design and the conceptualization of how the interaction with the citizens and the cooperation should work. And in both cases, science and design are centered on the citizens and the institutions which revolve around the citizens. So the municipalities, the industry, and the hospitals, and so on. So I think we put forward many ideas, and in the afternoon sections, we will be expanding on this and having opportunities to get more into details and discuss a little bit. So we also appreciated being wonderfully in time. It's almost 12, and this is not easy. And I leave to Elisa to provide the program of the afternoon, so we can reconvene, I guess, at 2:30.
Yeah.
Thank you. Thank you to the speakers. We really are grateful to them, and thank you to all the participants which have been listening and learning a lot of new things. At least for me, that was the case. Thank you.
Thank you both, and thank you, Valerio, for these closing remarks. Yeah, we will be again together at 2:30 Central European Time for the two parallel sessions, session number 4 and session number 2, that are very connected with these two keynote speeches. I really want to thank you again, the two keynotes, for their availability and their speech. And yeah, we will be together in a few hours. Thank you all. Bye. Bye.
Thank you all.